Hola, 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 hola. Probando. Ok, probando uno, dos, probando. Cheque, cheque. Welcome everyone. ¿Tal Diego? Estirándose. Está bien, excelente. Buenos días, mi estimado aprendices. Gracias, Diego. Gracias, Valeria, Ana y Marlon. Por favor, los demás, encender las cámaras. Gracias, gracias. Muy amable, muy agradecido. Vamos a ver los demás. Vamos, Sofía, Andrade, Jerónimo, Victoria, Fernando, Claudio. Vamos encendiendo las cámaras. Encendiendo. Perfecto. Vamos, Claudio, Fernando, Jerónimo, Amber, Valeria, please turn on the camera. Berlioz, please turn on the camera. Please. Thank you so much. Amber, Fernando, Celaya, please. Claudio, Camila, please turn on the camera. We are only 17 students. ¿Tienen alguna actividad ustedes antes de esta clase, muchachos? ¿O simplemente hueva del resto de la gente que no se quiso conectar? Mire la sonrisa, es hueva. Bueno, thank you. We're going to start with the class, actually the first lesson of the third quarter. In this case, we're going to start with the Hooke's law, and actually the central topic in this situation will be the simple harmonical motion. But before to do that, we have to prepare a little review according for the Hooke's law and the elastic potential energy, because this is a clear introduction before to analyze the simple harmonical motion. For example, in the simple harmonical motion happens when the net force of the simple object acts along the direction of the motion, and that's supposed to be proportional to the opposite direction. I'm going to translate that word definition simple merely words. For example, if you have elastic materials, you're applying one action force, that will be reverse that force with the same magnitude but in the opposite direction. And simply words, for every action force, there's going to be a reaction. Or in simple quotidian activities where you are lying down in your bed, okay, and you're starting to jumping, falling upward, downward, you are rebound around your bed. So the force that exert the spring will be equal for your heavy for your weight. For that reason, that force happens when you compress or stretch the spring. In that situation, we're going to have an elastic impact. Well, in that situation will be the simple molecular motion, ups and down, ups and down, just like waves, okay? And for this maximum exponent from the simple harmonical motion, we can using the three letters SHM, that will be the Hooke's law. The Hooke's law that will be given by the following equation. Fs equals negative k times x, where Fs represents the spring force, the letter k represents the spring's constant or constant of force, the x that will be determined the compressing distance. And as soon as you can see this equation, we have two units, the international system and the British system. In the international system, my dear students, the force is given by newtons. The constant force is Newton per meter, and the compressing distance is given by meters. In the British system, will be given by pounds, pounds per feet, and feet. Okay, that's why we call this equation is called Hooke's law. And this is important thing: the time required for one complete vibration is called the period of motion. For example, if the period of motion belongs 30 seconds, that will be the period time to complete the one cycle in 2 hours. So that's what I'll give you an example. Another example to the period of motion is like say in the Earth. Do you know how much time the Earth complete one lap around the sun? Everybody, who knows that answer? How many times how many days, seconds, I don't know, it takes the Earth takes a one lamp around the sun. What is the period of time?
365 days.
365, exactly. This is the period of time. That's why the quantity of time we will complete one single lamp. This is what we call period of motion, one complete lamp. And the reciprocal of this period is the frequency. So, in simple merely words, period is given by the capital letter T. Actually, I'm going to write that equation over here just for let you know. The letter T, hit it over here. This capital T represents the period of motion. And this equation could be equal to reciprocal value of the frequency. This letter F represents frequency, not friction force, just for clarify. Okay, that's why the reciprocal of the period is the frequency. So frequency equals the reciprocal of the period. Okay, and the question is, what is the frequency? As soon as you can read in this equation or in this definition, the reciprocal of the period frequency in the motion, which is the number of oscillations per second. Okay, it's depending what kind of a movement do we have. For example, if the movement of this object is given in simple harmonical motion, right, just like the waves, the unit from the frequency is given by hertz, capital H and C. Where are you going to find out that unit? For example, in your computer system, you're going to see how many megahertz, gigahertz, the the velocity of all computers given by millihertz and kilohertz and something like that. Actually, the cardiacal frequency is given by hertz because the period movement is like a simple harmonical motion, just like the waves. For example, but if this movement instead to be moves into waves, it's moving in circular motion, that unit on the frequency will be given by revolution because it's focused in the quantity of lamps given by the period of time. The number of lamps in circular motion we call revolutions. Actually, you learned that circular motion the last year. Do you remember when we studied the Kepler's law? We studied the cinematic or angular movement. Do you remember the torque, the torque position equilibrium, angular acceleration, angular velocity or speed, the cinematic of the angular rotation of body, rigid bodies. Okay, but this formula is not new for you because we studied already. What will be the difference? The difference depending what kind of movement do we have. Is a movement of weights. I mean, simple harmonic motion. The unit from the period, the frequency will be given in hertz. And if the movement is in circular motion, the unit of the frequency will be given in revolutions. And what will be the unit of time of the period? The unit of time of the period, my new students, will be given in seconds. So, and continue with this explanation, right? And we have the second level motion, the second level motion is given by the force that's supposed to be equal the product between the mass and acceleration, right? Well, and if you really want to know what would be the acceleration applying the second level motion, this acceleration is inversely proportion to the mass and the force because if to smaller mass, what does that mean? That means the acceleration will increase. If we have a heavier object, the acceleration will decrease. So acceleration equals force divided by mass. But what happened in this force, instead to apply a linear force or vertical force or slant force, we were talking about spring force. Well, the spring force is given by negative kx. For that reason, instead to divide force divided by mass, we change force by negative kx. Remember, the letter K represents the constant of force A represents acceleration, X represents the compressing distance, and M represents the mass. All right, what units we're talking about? In the international system, the unit from the acceleration is given by meters per second square. The constant force, just like that, that's 1 newtons per meter. The compressing distance is meters, and mass is kilograms. How about the Bridges system? In the Bridges system, we got the acceleration given by feet per second square. The constant force pounds per feet. The compressing distance is feet. And the unit of the quantity of mass is the slug, system linear unit of gravitation, SLUG. Now slot that means another thing. This is slug, SLUG, SLUG. That means system linear unit of gravitation. Because this again of words, this is an acrostic, just to tell you the truth. But if you're trying to looking for the translation for the word slug into Spanish, I said slug, not slot. Slug means baboso, babosa, algo como la baba, alguien que estás babeando. That means slug in Spanish. But remember, actually, this is not a word, this is an acrostic. This acrostic means system linear unit of gravitation. All right. So before to continue with this explanation, do you have some questions before to talking about the elastic potential energy? Hello. Houston, can you hear me? There's still somebody still alive? Or
Mister,
uh-huh.
just one question. So, entonces, en español, si encuentro también slug, es lo mismo, ¿verdad? No, no hay otra palabra para esa
Sí,
traducción.
es que mire, sí está la palabra slug, significa baboso, algo que tira baba. O sea, como
Sí,
cuando usted
pero
mira, pero es
pero
un
si hay un
acróstico.
problema como me lo pongo en
Es que,
español, siempre va a
ajá.
salir slug.
Sí, siempre va a salir slug. O sea, yo lo que quiero, lo que estoy explicando es que SLUG es un acróstico, que quiere decir en español sistema lineal de unidad gravitatoria. Solo para aclarar. Ahora, y yo menciono eso porque muchos años atrás, como unos 4 o 5 años, mucha gente en vez de escribirme slug, me escribía slot. Pero ustedes saben bien que esa no es un acróstico, ese sí tiene significado y con el respeto, ¿verdad? Yo respeto sin ánimo de querer usar esa expresión, pero lo aclaro para que no me lo vayan a poner. Inclusive hasta el año pasado me pusieron slot en una unidad de masa y le puse 0 a la persona. Viste, pero es que esa unidad de masa no la conozco, le dije yo así. Pero en fin. All right, let's continue with the second part of the problem. The elastic potential energy. Actually, this is not a new term. This is just like a review. If you remember, what is the definition of this elastic potential energy? In simple words, it's the quantity energy stored into stretch or compressed spring in some other elastic materials. Simple words, when you compress a spring, you're going to have elastic potential energy. What will be the equation? The equation is given by UE. Well, actually, in the textbook, using the letter PE, P, capital P and capital E, but this is not professional. Don't like it at all. So let's go to continue with internal energies. So UE equals 1/2 kx squared, where UA represents the elastic potential energy, the K represents constant of force, X represents the stretch of compressed distance, all right? And you know the units. Because the elastic potential energy is the capacity to create work, obviously this is going to be a work, right? And the unit from the elastic potential energy international system will be given in joules. British system, pounds per feet. Constant force, newtons per meter, and British system, pounds per feet. And the compressed stress distance, meters and feet. All right. And the last part, at least for the first part of this chapter, because there's a lot of formulas, and actually in this quarter, to tell you the truth, we're going to study only couple chapters, like chapter 13 and 14, because both chapters are so extensive. For that reason, we're going to see only 2 chapters. And this is the first part of the chapter 13. And the velocity of the objects as a function of the position when the object is moving with simple mechanical motion, it's given by velocity equals positive, negative, because remember, every time they want to take a square root could be a positive, negative velocity. It's given by square root of k squared a at the second power minus x second power divided by m. All right, what does that mean? The x, is the stretch of compressed distance. M represents the mass. K is the constant force. But what does the B actually is the velocity? But what does that mean, the letter A? The letter A, that means the amplitude of the weight. Just for to give you an example. Actually, we are studying logarithmic functions in this quarter in math that will be useful in physics class. And also, we're going to study trigonometric equations and entities. So those things will be stick together with this lesson. And we're going to learn how to set the graph for the sine and cosine functions. For example, I'm going to give you the example just for let you know what will be the amplitude. What does that mean, the amplitude in simple merely words? Okay, this is, you can imagine, this is the coordinate plane. Sorry. This is going to be the coordinate plane. All right. This is the angles in radians. Hold on. And let me show you what will be the relationship between this. All right. This letter X represents the angle, and the letter Y in the Y-axis represents the distance. So in this case, we're going to use the Y-axis like a vertical distance. Y and negative Y. I know in math, in the math class at the moment, I'm going to explain you with more details how we can create this graph. For example, we have the function, we have a given function like a y equals sine of theta, okay? And we have to skip the graph since the zero, since the zero, the angle from 0 units, angle theta, and the y-axis, 0, pi half, pi, 3 pi half, and 2 pi. And I have to, well, we have to graph this equation, all right? So this is going to be -1, and this is going to be +1. So what will be the behavior? Well, you're going to learn in math. This is one singular topic that we call unit circle. If you really want to know how to calculate those values from Y, the only thing that you have to do is set up your calculator in radians, make sure the calculator has the letter R, capital R in the calculator, and substitute LA value. You're going to see sine of 0 is 0, sine of pi half is 1, sine of pi is 0. This is going to be -1, and the last one will be 0. So according for this situation, we're going to connect those points here, here, another one over here, all right? And this is going to be the graph, just like a mechanical motion, because this has a shape of wave, all right? So why I'm telling you this one? Because to explain you what does that mean of the amplitude will be the width of the weight. I mean, this distance, the separation, the vertical separation between the one point to another one. So I have a question for you. And actually the period of time will be the cycle of time that you're going to start from the origin until the value from 2 pi. This is given the period of time, by the way. But I have a singular question for you. Could you like to tell me what is the value from the amplitude? Seeing that, seeing the graph, would you like to tell me what is the value from the amplitude?
1.
Exactly, 1, because it's the vertical distance, it's the width. And actually, we're going to learn another concept in the in a few weeks later, that the separation between one wavelength, one wave to another one, that they call wavelength. And this is the separation, the horizontal distance between one crest to another one is what we call the wavelength. And this symbol, the wavelength, this is what we call a lambda. Lambda, this is the separation between the one wave to the another one. So the amplitude in simple merely words could be taken like a maximum height. Then we're going to have a one graph in simple harmonical motion. And the letter X could be some kind of distance. Vertical could be some kind of vertical distance. When the, how to explain you, when the, every time that the object reaches the maximum height, we can say with the velocity 0, when we set the amplitude that will be equal to the distance x. That happened when the velocity gave us a value from 0. Okay, and this is at least the first part of the theoretical part with the Hooke's law, elastic potential energy, and the velocity in function the position. Questions? Don't worry about it with the graph. This explanation, I'm going to extend it with more details in math class, in the math class. Don't worry about it. This is the graph of sine. You're going to learn in algebra 2, the graph of sine, cosine, tangent, secant, cosecant, and cotangent with particularly details, specified details, and you're going to learn how to solving trigonometric equations. But this is going to be math class. So at the beginning of this moment, the physics class with the math class will stick together because some kind of topics in physics, you're going to relationship in math, and the math topics in math will be relationship with physics. So welcome, we're going to fusion the two classes. Will be interesting. Questions? Preguntas? No questions? All right. May I erase the first part of the whiteboard, the first column? ¿Puedo borrar la primera columna? ¿Sí o no? All right. Let's begin. All right. Let's begin. The example number 1. I know we have missing a lot of definitions, but I'll do it step by step because I don't want to get confused because those equations so similar between one to each other. We have a one singular example. In the example number 1, the example number 1 says, an archer must exert a force of 375 newtons, 75 newtons on the bowstring, in the bowstring shown in figure. Shown in figure. Show in figure. Uh-huh. Shows in figure such that the string makes an angle makes an angle of 35 degrees with the vertical. With the vertical. Uh-huh. Period. Letter A. Determine the tension in the boundary. That was the letter A. Letter B. Letter B. If the applying force, if the applying force is replaced by a stretch spring, as in figure, okay, and the spring is stretched is stretched 30 centimeters from in on stretch. On stretched length what is the spring constant? What is the spring constant? All right, before to do that, it's going to draw the pictures, the problems. Ay, vamos a ver. Bueno, por ahí se va. Se supone que este es el arco. Tararara, 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 tararara. And we got the strings. And that's supposed to be the applying force. The applying force F. And we got the angle theta. That's supposed to be the angle theta. This is the picture of the first condition in the letter A. How about in the letter B? In the letter B, we're going to drop once again the same boat. Mhm. This is the same. Okay. All right. This is the same boat. We have the two string. All right. We have this vertical angle theta, but instead to apply this constant force, we have a spring located over here. We have a spring. And this spring is located at the wall. And this is supported like a wall. This is the wall. Right? This is going to be the condition from the letter A, and this is going to be the condition from the letter B. All right. So what we have to do, chon, 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 chon. Let's working with the first one. All right, the question is, we have to looking for the tension in the bone spring, okay? So what is the first thing that we have to do to determine the tension in this bone spring? ¿Qué es lo primero que tenemos que hacer aquí? The golden rule. What is the first thing that we have to do in this case? To determine the red one, the tension of the strings. ¿Cómo se llama eso que hay que hacer? Lo primerito. Ay, lo puedo mandar a this one.
Free body diagram.
Free body diagram. Perfect. This is the first thing that we have to do. The free body diagram. All right. This is the free body diagram. This is the coordinate plane. Y, negative Y, X, and negative X. What forces do we have? Okay. For example, we have the constant force F is given by 375 newtons. Okay, and we have the tension of the string. We can call this one tension 1. This is going to be tension 2. And the angle with the vertical, because the problem says vertical position, the angle will be given by 35 degrees and 35 degrees. Okay, this is going to be the free body diagram of the letter A. So let's going to start. Addition, Y forces of Y positive equals 0. So we have, actually, we have the positive tension 1 cosine 35 degrees. Okay, positive because Y positive. Subtracting tension 2 cosine 35 degrees. And this equation that's supposed to be equal 0 because this movement is at rest. So that reason, tension 1 cosine 35 degrees, that will be equal tension 2 35 degrees. And if you're solving for tension Y, because cosine 35 and cosine 35 is the same, it can be canceled. So we can conclude tension 1 will be equal that tension 2. Or one hand. Now, the addition of the F forces. F forces to the right side positive equals 0 because remember, this bow is at rest. We are not moving. We're not performing any movement. So what forces do we have? We have the constant force of 375 newtons positive, subtracting tension 1 sine 35 degrees minus, because tension 2 is negative, sine 35 degrees, that will be equal 0. All right. Remember, T1 equals T2. For that reason, we can call this one like a lightness. 1 plus 1 will be 2. So 375 newtons over twice sine of 35. that will be equal tension 1. How do I know that one? Because both quantities subtracting passes to adding. Tension 1 plus tension 1 will be 2 times tension 1 sine 35 because T1 equals T2. And because 2 times sine 45 is multiplying, passes to divide. So for that reason, the value of the tension 1 will be given by, give me a hand, please. Hey, make sure in this case, please set out your calculator in degrees mode. Degrees. Be careful because we're not talking about simple harmonical motion in this case. Degrees. Make sure the calculator must be set up in degrees. All right. So the answer will be, what will be the answer? Its approach is 327, right? 327 newtons. This is by one hand. In the first section. Well, in the second section, my dear students, the problem is perfectly clear. The property in the second part of the problem says, okay, how about if we substitute this applying force by a spring? All right, the spring stretch actually stretched by the 30 centimeters. So the question that they're asking for, what will be the spring constant? So you know, the force applied in this situation, at least in this position, I'm going to use the not red one, no, the blue one. That's supposed to be, yeah, 375 newtons. And the distance, X, that's supposed to stretch the spring, that will be 30 centimeters, or 0.30 meters. All right. So what will be the big deal? Well, at the moment we're going to apply this constant force. Remember Hooke's law. The only thing that we have to do is apply force, spring force, that's supposed to be equal negative X, negative K times negative X. So this negative, we're solving for K, we got negative Fs divided by X will be K. So why is negative in this situation? Because the spring force, this is not located into the, this is not located into the wall. They're acting actually moves to the right side, because at the moment we're going to compress the spring, obviously these two strings move to the right side. The force that will be positive, but because this 30 centimeters is reduced their distance, there's a compression. So a compression means a negative distance. For that reason, at the moment we're going to apply this equation, I mean negative 375 newtons, we must divide it by negative 0.30 meters, because this is going to be a compressed distance. And for that reason, negative times negative will be positive. So would you like to tell me what will be the answer from the letter B, please? ¿Alguien? 375 entre 0.30. Hello. Someone?
1250.
Exactly. 1,250 Newton per meter. And this is going to be the solution set for the problem number 1. Letter A and letter B. If God wills, tomorrow, on Monday, not on Monday, on Tuesday, because there is no physics class on Monday, we're going to continue with solving of fruit problems, Hooke's law, elastic potential energy, frequency, distance, conservation energy, something like that. So guys, thank you so much for your attendance. Have a great and wonderful weekend. Take care of yourself.
Mr.
Uh-huh.
Can you take a picture with your phone of the graph, please?
Okay, hold on a second. Hold on. Sigo pensando, Marlon, sigo pensando. All right. This is print screen. Hold on. Vamos a ver. Cierro esto aquí. Ay, déjenme buscarlos que me dan álgebra. Algebra 2 and physics. Here we go. Did you receive them? ¿Lo tienen? No, I sent it for
Yes.
already. I sent it with the WhatsApp group. All right. Thank you so much for the attendance. Have a great, wonderful weekend. Bye-bye. So long. Take care of yourself. Bye.
Listen.
Sí, sí, sí.
Una pregunta.
Dígale que
Cuando-
sea rápido porque tengo una emergencia de carácter orgánica urgente, de esas que son muy grandes. Dígale.
no, que si la atención, uno,
Ujú.
porque era que tenía cos y...
En Y,
Ajá.
porque el ángulo está con la vertical. Acuérdese, cuando el ángulo descansa en el eje Y, es coseno para Y y seno para X. Por eso. Ahora, si
Ok.
usted no quiere usar ese ángulo de la vertical, a 90 réstele 35, son 55. Descarte 35, ponga 55 en la horizontal y use lo normal. El ángulo coseno de 55 en X y seno de 55 en Y, y le va a dar exactamente lo mismo.
Ok, gracias, mister.
Bye bye. So long. Take care of yourself.